Assalamu alaikum. My name is Noor Muhammad, and today our topic is parsing techniques. So let's discuss about what is parsing and what does parsing is. So let's start with parsing techniques. In the parsing techniques, the parsing is taken from the Latin word that means parse, meaning parsing or analysis is the process of analyzing or a string or symbols. Either it can be natural language or it can be a computer language according to the rules given to the formal language. So it will discuss about it will all about parsing. So parsing mean determining the structure of an expression. It determines and determining the structures of an expression. That's mean parsing. So first of all, we have what does mean parser. What does parser means? So parser is that does not use any ambiguous grammars. In the parsing technique, we have some production rules. We use some context-free grammars, and for a particular production, we have some action associated with them. Understand? It's mean that so when we use a context-free grammar, there is an action that is associated with the production rules, so that's the associated association is known as parser. If we talk about grammars, which grammar are we are going to use in parser? That is, uh, don't allow the parsers does not allow any ambiguous grammar. There are different types of parsing technique we will read about. So we will see that which parsing technique use ambiguous. So first thing is that the parsing technique does not use any ambiguous grammar. Okay, so here you can see that the parser is a compiler or interpreter component that breaks data into smaller components or elements or for uses for easy translation into another language, because it translates the given expression or given component into another language by using parser by the given conditions in the syntax analyzers or whatever. We will discuss about this later. So the parser takes input in the form of sequence. It means in the form of sequence of tokens or program instruction, and usually build a data structure in the form of parse tree or in the form of abstract syntax tree. Here you can see that the parsing is that can be defined as the process of analyzing a text which contain a sequence of tokens to determine its grammatical structure. It determines the grammatical structure of the given expression and then translate into the other language. So lexical analyzer give the token to the syntax analyzer to grammar of the source program language. So in the syntax analyzer we have the parser. So the parsing technique parse the language, convert into the other language, and give us the given result. So it means the in the compiler model, the parser obtain a string of tokens from the lexical analyzer and verifies that the string can be generated by the grammar for the source language. The parser returns any syntax error for source language. It means that if the syntax analyzer if the lexical analyzer give any wrong language, wrong components, so syntax analyzer determine whether the language is true or false. So at the end it will determine that it will be without error, the syntax is without error, or it will give success or failure. So now we'll discuss about there is some examples of parsing. So construct the given grammar. Here is string s plus s, asterisk s, and a or b. Then we have to make this, construct this. We have to produce this language from this one. So you can see that the first is s string, then next string is s. So s plus s, you can see that s plus s. Then from s plus s, the production rule is the last one is s. There is s steric s, then there is s steric s, and the last is a b. There is a and b. Here you can see that we have to complete the strings. There is a b b. That's the reason we write in multiple times. And the given language, the given result is that a B static B, and here is the string. There is the converted language for the given grammar. It means that it moves from the parser or syntax analyzer, and the syntax analyzer convert the language and give us the result, whether it be success or failure. So if you did not understand the previous language example, so we will discuss about this, because this example is much easier than the previous one. There you can see that there is equal sign, and there is minus and static sign. There is minus and static signs, and then you can see that the next string is A, then D, then F. The production rules say that the it does not allow any ambiguous grammars. So here is D and A, D and F. You can see that the final result is this. Now we'll talk about the parsing techniques. There are different types of parsing techniques. Okay, so the first common here is that the first thing we have to understand is that the parser does not use any ambiguous grammar. Mean if grammar is ambiguous, then we cannot use in the form of parsing techniques. So it does not call parsing techniques if their grammar is ambiguous. The first thing you need to understand about this. So parser are of two types. There is a top-down parser and the bottom-up parser. Now if we talk about the top-down parser from the left side, the top-down parser technique is that it can be further divided into two more parts, that is backtracking and predictive parsing. So if we talk about TDP with backtracking, TDP backtracking is that top down parsing backtracking, full backtracking. Then we use our one technique that's been called brute force technique. So so when we need to solve the backtracking, so we will use the brute force technique. Now if we have TDP without backtracking, that is also called predictive parsing. That TDP without backtracking, that the grammar should not have left recursion means, and grammar also should not have non-deterministic. The backtracking grammar should not be non-ambiguous, or it use the brute force. And the other one, predictive parsing, the grammar cannot be non-ambiguous, and it should be a non-deterministic grammar. So the predictive parsing can be further divided into two more parts. That is recursion and non-recursions. One is recursion and the other one is non-recursion. Descent parser. That is called descent parser. So in this we will discuss about different types of parser, top-down parser and a bottom-up parser, and some working. In some books, the recursion and recursive and non-recursive come under the trajectory of predictive parser. Now if we talk about this bottom up parser, there is LR and SR. This we will discuss about one technique. SP parser means shift reduce parsing, and the left to right parsing, that is LR parsing. This is the only parsing technique which is used ambiguous grammar. It means that the LR the only parsing technique which use ambiguous grammar. The first we will discuss about the parsing technique is that which does not use any ambiguous grammar, but LR is the only parsing technique which can be used ambiguous grammar. So operator procedure, this is also known as operator procedure parser, that is also known as shift reduce parsing. The LR, there is no parsing technique where we can use ambiguous grammars. The LR mean left to right. The LR mean left to right. The input from left to right to RMD. Scan the input from RMD from left to right. The top down and bottom up parsers. In this we will discuss about what is the use of the parser, and if given string in the grammar, whether the string is generated by the using parser tree or not. Okay, so there are two types of parsing techniques: the top down parsing and the bottom up parsings. The top down parser is that it start the parsing from the top to the bottom, and start from the root and it ends from the and at the bottom. Now we'll read the slide. Start at the root of the derivation tree and falls in and fills in. Pick up production and tries to match the input. And it works like same that when the production rule is given to the syntax analyzer or and when the grammar is passing through the syntax analyzer, then it produce a given language. Then in the top down parser it produce from top to down, and the bottom up parser is that it moves from bottom or down to up, then starts at the leaves and fill in the from top, starts in the state valid from legal first token, then it moves forward. Now the design of parsing technique, top down parser, it pop the non-terminal on the left hand side and the production at the top of the stack and push its right hand side string. If the top symbol of the stack matches with the input symbol being read, pop it. Push the start symbol S into the stack. If the input string is fully read and the stack is empty, go to the final state F. That's the total design of the top-down parsing technique. Here you can see that there is an example of top-down parsing technique. There is an S and it will produce A and D. Here you can see that S string. There is an S string that produce language A, small a and capital A, then small d. And after this, the capital A will produce B. Here you can see that the capital A will produce B, or the capital A can produce C. Here you can see that the capital A can produce B and the capital A can produce C. And and here you can see that the B S again, S can produce A or B. We will discuss about this production rule and this production rule. Now we are going to discuss about this one, this one, and this one. And here you can see that S or AB, S A small a and the capital B, and the capital B can produce C and D, C and D. This is known as top-down passing technique. Here you can see that always expand the leftmost non-terminal that we discuss in the parsing techniques of the top-down. What's the design of the top-down passing technique? Always expand it is always expand from the leftmost non-terminal. Here you can see that we have id plus id static id. The e plus e is given, then e is add with e. That production rule is applied on the given language. It means that this production rule is applied through the lexical analyzer and it will produce this. Then next is that there is an id, it will connect e with id, then again apply the production rule, then e static e, the e will connect with the e static and e, and then e will connect with the e id. Here you can see that again e with id, it means that it will produce this. Again we see that it will move from, see the given diagram, it will move from to down top to down. Okay, that is known as top down. So the first problem in top down parsing is backtracking. The backtracking, because the backtracking is a technique in which for expansion of non-terminal symbol which use an alternative symbols. So that's the reason there is a big problem for that. So suppose the given production rule, you can see that there is an SCAD. There's this example is backtracking. So there is CA and D, capital A and D, and then A will produce A or B, and then A can produce A. So left recursion is removed. The next problem of top-down parsing is The left recursion is removed if the parser perform top-down parsing. And the next problem is left factoring. The left factoring is removing the common left factor that appears in its production of the same non-terminal. It is done to avoid the backtracking of the symbol. So you can see that to build a parser, it repeats the following step until the fringe of the parser tree match the input. So the step one is that at a node label A, select a production rule and we construct the child of this. Then step two is that when a terminal is added to the string that does not match the input string, then we use to backtrack the symbol. Then the step three is that find the next node to be expanded. And now we'll discuss about bottom up parsing techniques. The bottom up parsing technique is that it moves from bottom to top. It means that it moves from bottom to top. This is known as bottom up parsing techniques. So bottom up parsing start from bottom and the string come to the start symbol using parse tree. It means that it comes from the it use tag to store both state and sensational forms. Here you can see that the example. Here we have int and int. The int will added with e. We are moving from bottom to top, bottom up. We are moving from bottom to up. Okay, int with e, then again int with e, and then again exchange with e. Here you can see that. Here you can see that e and e, and these are connected with int and int. We are moving from bottom to top. Again e plus int. E is added with int, and then again at last e is production rule. E is the string, given string, and the production rule is that e, and there is the int. Then we start from the bottom and we move towards up. So the design of the bottom up parser is that push the current input symbol into the stack, replace the right hand side of the production. Here you can see that we start from the right hand side of the production rule. If the top of the stack element matches with the production rule, then production symbol input pop it. If the input string is fully read and only if the start symbol s remains in the stack, pop it and go to the final state. So if we further discuss about what is the bottom up parser, so the bottom up parser is that it is just an efficient build an idea to the top down parsing preferred method in the practice. So this technique is about bottom up parsing. So thanks if you understand this topic, and okay, Allah Hafiz.